Okay, very well. So can you all see it well?
Yes.
Very good, thank you. Okay. Now, these are basic things about inverse function. So again, the function where it takes the domain and range, the inverse function of that function will take the range to be the domain and the domain to be the range of the inverse function. So yesterday we talked about this already, right? So let me do it quickly here. So the derivative of logarithmic functions is given by these formulas. So what we need to do is to memorize them and do more problems, we'll be fine. Okay, the first formula is that d over dx of logarithmic base b of x, it will be 1 over x times natural log of b. Okay. And therefore, the special case of this, which is log base e of x, what is it? So what is a log base e here? Yeah, ln. Thank you. So the base, if the base is the constant e, so we write it ln x, natural log of this. And from this here, right? From this formula, what do we have here? So applying this formula, what do we have?
1 over x.
Very good, thank you. Who was saying that?
It was me, Daniel.
Daniel, thank you, Daniel. And here, Carson, thank you. Okay, so because here from this, it is natural log of e, and natural log of e, it means that we ask ourselves which number should we raise to that, what is the, so natural log of e simply be 1, okay? So think about it. So therefore, we have 1 over x. Okay. More general, we use the chain rule. If d over dx of natural log of a function u, where u is a function of x, right? It means that we need to use the chain rule. In this case, what does it mean? The derivative of ln u and the chain rule tell us that. What is it? Yes, d over du, and du over dx, right? And u in this case here is u of x, and the y is ln u, right? D over du of ln u, right, from this formula. This is d over dx of ln x. So now, in our case, u is a variable. So what do we have? Louder? Perfect, thank you. And du over dx, what is it? Yes, it is u prime. And u prime is a whole number. So we can write it this number divided by 1, right? And the product of two fractions will be, yes, it will be u prime divided by u. It's quite easy, right? So now let us play with some example. These are beautiful formula. Just memorize them. And now let us find d over dx of ln sine of x. Right? Now look at this. What is u in this case? Perfect. Thank you. Sine of x, right? Therefore, from this formula, what do we have? This is u, right? Sine of x is u. So derivative of this will be
Would it be cosine over sine?
perfect. But let us do it slowly. Sine of x prime, right? Divided by sine of x. Who was that? Who did say that? And derivative of sine give us cosine. Thank you. And we know that cosine over sine give us cotangent of x, right? So is it clear? So from this chapter, what we need to do is to play with formulas so we can master it easily, right? In the previous chapter, section 2 is a little harder because we play with some definition and it takes some time to get used to it. So that is an example. Now let us play with this. If this is sine, right? Then let us play with a similar one. Find y prime for y is natural log of cosine 2x. Oh, it looks scary. Okay. Now, y prime, which is d over dx of this ln cosine of 2x. And in this case, what is our u? Perfect. We determined that, okay, u is cosine of 2x. And from the formula, what do we have? Again, please. Perfect. The derivative of cosine of 2x divided by itself, right? It's Carson, right? Thank you. So derivative of cosine 2x is a little bit tricky, right? Here, cosine is a function of 2x. So again, we need to use the chain rule, okay? This is imagine, okay? This is cosine of another function. So it will be, what is it? Yes, negative sine of 2x, and then multiply with the derivative of the things inside here, in this case, which is 2x. Very good. And the denominator, we just rewrite it. So very good. Thank you, Yasini. So we see that, what is the derivative of 2x here? Perfect. And therefore, we can bring this constant in front of this, and the negative sign, we just rewrite it. 2 times sine of 2x divided by cosine of 2x, right? In the top, the numerator is a product. So we can write it negative 2 times, what is the fraction here? Perfect. Sine of 2x, cosine of 2x, they're the same thing. But from this, we can write it as negative 2 times what? Yes, tan of 2x. Okay. So is it clear? Just follow the formula, write it slowly. And finally, we get the result. Okay, so now let us play with this one. Y is x to the square root of x. Huh. Do we have any formula of this? We know the power rule, but in that case, the power would be a number. But in this case, the power is a variable. We haven't studied it yet. The power rules, we study the variable on the power, but the base is a number. In this case, the base is a variable. We haven't studied a formula to solve it yet, right? But the logarithmic formula is very beautiful. It tells us, it gives us a better way to compute the derivative of this. And let me remind you some of the properties. Before doing this, let me just write down some formulas that you know before, but may not remember. So the log base A of x plus log base A of y will be log base A of x times y. Okay, sum of logs becomes log of a product. Log base x, base A of x, subtract log base A of y. I'm sorry, this is y. It will be the log of a quotient x over y. Very interesting. And another one, log base A of x to the n, it will be n log base A of x. This case, so we see that here, the power here is brought down to this, and it becomes like this, right? So how about this guy? To avoid confusion, let me just remove this. Log base A of n root of x. Can we find it? Any suggestion? This is any number, the n. So be careful. This is n root of x becomes x to the 1 over n. So be careful. And again, from now we can apply the formula of this here, right? This is the power 1 to the n. We can bring it down. So, and what is it now?
1 over n log n.
Thank you. So Whelan and Ethan, Carson, sorry. And who was talking on Zoom? Who was that?
I was Gavin.
Gavin, thank you, Gavin. So, very good. So these are the formulas. Okay, now, so which formula we can apply it? So if we take the natural log both sides of this equation, y equal to x to the ln square root of x, right? Let us take that, let we take the natural log both sides and what we get. So if we take the natural log from the left, and the right hand side will be natural log of x to the square root of x, right? This allows us to do it better, easier, because this is x raised to the power of square root of x. So we can apply which formula among these? Yeah, the third formula right here, right? It means that, how does it become? Perfect. Square root of x times ln x right here. Okay, very good. Thank you, Carson. And now the left-hand side is a function of x, of y. Y is a function of x. And the right-hand side is a function of x. So we can use the implicit differentiation to compute it, right? So what should we do? Very good, thank you. We take derivative of both sides, d over dx of natural log of y. It will be the derivative of the right-hand side. Very good. So how does the left-hand side becomes? So we can use the chain rule right here, right? And what is it? Oh yeah, no, we have the formula, so we can apply it directly. ln of y, where y is a function of x, it will be y prime divided by y, right? That is from the formula. Or you can use the chain rule to write it easily. And the right-hand side, which rules should we use? Yes. It is a product of two functions. The first function is square root of x. The second one is ln of x. So the product rule tells us that, okay, it will be, yes, perfect. Thank you, Rami. So the first function prime times the second one, and plus the first function times the second one prime. So now apply the rules to this function. On the right-hand side, what is square root of x? Derivative of square root of x? Yes, 1 over 2 square root of x, right? So when we do it many times, we will remember it easily. And here is ln of x. Square root of x, we just rewrite it. And what is derivative of ln x? 1 over x. Thank you. So, can we simplify this fraction? The second one? Square root of x over x. And we know that x is square root of x, then square, right? It means that the denominator, we can write it, square root of x times square root of x, and then they simplified each other. And what do we have? Perfect. So, and in the first fraction, it is ln, we can write it this way, right? ln divided by this. And here, the second one, it is 1 over square root of x. Very good. Now, can we sum them up? Perfect. These are two fractions. They don't have the same denominator. We cannot add them up. But in order to do so, we need to find the common denominator. So we know that the common denominator is 2 square root of x. It means that this guy, we need to multiply by 2 in the denominator. But somehow we divided by 2, we need to multiply by 2 to make it even, right? Now they have the same denominator, so we can sum them up by adding the numerator together. It will be, what is it? ln x plus 2, perfect. Divided by 2 square root of x. And the left-hand side is y prime divided by y. So we can multiply both sides by what to get rid of the y here? Yes, multiply y both sides, right? Then the left-hand side, y will cancel each other, and y here now it becomes in the right-hand side, okay? I would like to point it out right here because some of you did it wrong in the test. Look at this. This is a fraction multiplied with a whole number. Therefore, it should be, what is it in this case? If I write it in terms of one fraction only, is it correct here? No, it's not correct. Very good. Because here, when you do it this way, you forgot foiling it. So we should be very careful. This is y multiplied with the whole numerator here. Then when we FOIL it, it will be different from ln x plus 2y. So be careful. Very good, thank you.
I have a question.
Sure.
When it says up there, the square root of x times 1 over x, and then in the next step, it's become 1 over the square root of x.
Okay.
Is that right?
That is correct. Because square root of, because x, we can write it square root of x times square root of x, right? X is square root of x times square root of x. Do you agree?
So I'm wondering why it wouldn't be the square root of x over 1 times 1 over x, and it would end up being the square root of x over x.
That is correct. You're right. There's nothing wrong there. So this one is definitely, so square root of x times 1 over x. It is square root of x divided by square root of x times square root of x, or square root of x divided by x. I agree. That is right. But we see that the fraction, the first fraction, there is a square root of x in the denominator. Or without seeing the that fraction, we see that this one we can simplify it, right? Because here it is square root of x divided by square root of x times square root of x. So we can either simplify it or let it be this way. So if we simplify it, it becomes 1 over square root of x, as we have written right here. If you do not simplify it, it is square root of x divided by x. It is still okay. There's nothing wrong. But because we see that the first fraction here, there is a square root of x, so we want somehow add them up. That is why we simplify it here. So are you comfortable with that now?
Yeah, I see it.
Thank you. Is it, who are you?
As Daniel.
Daniel, thank you, Daniel. So, very good. This is a psi computation, so let me just put it in the box right here, like this. Okay, now we know that y is, by definition, it is x raised to the power of square root of x. Therefore, from this part, this is y prime, right? So let us continue. Therefore, we have that y prime. We substitute y by the true forms of this. Which is x to the square root of x, right? So, and that's it. That is y prime. So the log function allows us to compute something very complicated right here. in an easy way. Okay, very good. So do you have any question? Good job. So how about this one? Let we play with a slightly different problem. Okay. How about y is sine x times x to the square root of x. Find y prime. Ooh. Yeah. So what should we do now? If we do the product rule, very good, we can do it. But let us try. D over dx of y will be d over dx of sine of x times x square root of x here, right? Then in the left hand side, what do we have? Oh yeah, y prime. And the right hand side, okay, cosine x and very good, plus derivative, right? But we know from the previous one, we know that derivative of x to the square root of x is this guy, right? We don't have to do it again. We just bring the result here, replace this, and we're good, right? So we just rewrite it. Very good. Just to avoid confusion, let us write the bracket here. Very good. Wait a second. Let me see. It is true. Yeah, that is one way. But go home and try to play with hold on, wait a second. Go home and play with this. If you take the natural log both sides, go home and do it this way, like the one we did previously, and see the result. What is the difference between these two methods, right? Okay? Go home and do it. Very good. So in summaries, in order to deal with these complicated functions, what we need to do is to take 3 steps. The first step is to take the natural logs both sides. In the second steps, differentiate with respect to the variable x. And the last step is to solve the resulting equation. To find y prime. These are the steps, right? And now, let me give you an example so that you can go home and play with that. How about this one? If y here is x to the 3/4 times square root of x squared plus 1 divided by 3x plus 2 to the 5. So definitely we can do the quotient rule, right? Quotient rule where the function f is the whole things here, and the function g is the denominator. And then after that, you need to deal with the product rule, because here is a product, right, in the numerator. So it will take a lot of work. If you use the log formula, it is much simpler. So go home and play with that and see, okay? So review the formula of log function. Now, so the number e, we have seen it many times, right? And if we would like to compute the number e, is a limit. We know that e is approximately 2.7 something. That is the number e. And now we would like to compute it in the limit form. Now, let us consider this function. If f of x is natural log of x, right? So what is f prime? 1/x, very good. 1 over x. Then, how about in the definition? Let us compute from this formula. Therefore, we know that f prime at 1 will be, yes, 1 over 1, which is 1. Substitute here. That is from the formula. We can do it using the definition of this function at 1, derivative. Do you remember the limit of what? We need to compute the limit of derivative at 1. Yes, f of x plus h minus f of x in this case is 1, right? Divided by h here. So now from this formula where f of x is natural log of x, right? So what is f of 1 plus x h here? You see that the input of the function now is 1 plus h, right? Yes, it is natural log of 1 plus h. And how about f at 1? Yes. And the denominator, we just rewrite it. So what is natural log of 1? Perfect. Natural log of 1 is 0. Because natural log of 1 is log base e of 1, right? Which we know that any numbers raised to the 0 equal to 1, right?
Huh?
That is why we have natural log of 1 is 0. So we know that this guy is 0. So it means that the limit here will be the limit when h approaches 0 of natural log of 1 plus h divided by h, right? But now, if we separate this into a fraction, 1 over h, and then natural log of 1 plus h here, what do we have here? The log formula tells us that we can bring this constant, this number, up to the powers of this guy, right? It means it will be natural log when h approaches 0 of natural log of 1 plus h raised to the power of 1 over h here. In other words, it is limit of h approaches 0, natural log of, can we write it in terms of a root function? What is it here? Yeah, h here, right? But now, okay, and h here is simply a name of a variable, right? So we can change its names and name it as limit when X approaches zero, ln square root of x, 1 plus x, nothing's changed. We just changed the name, right? But now the left-hand side, we know that it was 1, right? Because f prime at 1 is this guy. Or let me just write it here, 1 equal to f prime of 1. So now, if we raise e to the power of both sides, it should be the same, right? Okay. We raise e to the power of these two sides. It should be the same. And the power function here is continuous from the limit rules. It tells us that, okay, the left-hand side is e, the right-hand side should be equal to the limit of e to the ln of square root of x plus 1, x here, from limit, continuous rule. And e to the ln gives us limit when x approaches 0 of square root of x, x plus 1. This is the true forms of e in terms of limit. So in the future, you may see it. So I think we're good for today. And there's an office hour from 3:30 to 4:20 today. If you have any question, please come to my office hour and please help you. And you all have a good one.